Hey woodcutters, TopSaw here. Today's video is going to talk about router bits. I have a pretty wide variety of router bits. I'm going to talk about where you might want to use some of them or the other ones, and just a general overview of router bits for the wood shop. Actually, before I start going over all of these router bits, let me just say a piece on safety. Do not use a router unless you've been trained properly. Safety has to be job number one. Always wear your safety glasses. Keep your fingers far and away from any router bit. If you run your finger into a router bit, it'll be more like blowing that finger up than actually cutting it. Okay, so to get started here, I know this looks like a crazy amount of router bits right here, but really to get started, the first thing to talk about is a collet. So this collet is what holds the bit in the router. This is a 1/4 inch collet. And these router bits here have a 1/4 inch shaft. Both of these trays have 1/4 inch shafts, and then I jump up to a 1/2 inch shaft like this. So with this large 1/2 inch shaft, you got to change your collet out to get a 1/2 inch collet. You could buy a collet and a shaft diameter, pretty much whatever you want. They make them 3/8, 5/8, 3/4. The advantage of a 1/4 inch shaft is they're not very expensive. They're easy to use, and they could get into kind of tighter spots. The reason why you would step up to a 1/2 inch shaft like this and a 1/2 inch collet is because the heavier this material is, the less it's going to deflect. And deflection is really a big idea. As you're running this bit across a part and you're hitting it and pushing it hard, then it's going to start to bend a little bit. And a 1/2 inch shaft is going to prevent that sort of deflection. So that's why you would step up to a larger shaft. There are two primary types of router bits in a wood shop. One is a bearing bit like this, where there's a bearing on the top of it, and then the other is a non-bearing bit, where there's no bearing on it. How a bearing bit works is your material runs up against that wood, and that bearing runs on your wood, and that's how you get your reference. And then the other type is a non-bearing bit like this. You just kind of freehand it. So whether you're on a CNC router and the machine's moving it all over the place, or you're using a handheld router, this bit will not be controlled by the edge of the material, but rather by the way you move the router itself. Taking a look at some of these bits to kind of identify the different parts. Let's take a look at this 1/4 inch shaft, non-bearing bit. As I look at it in profile here, it is a flat end 1/4 inch mill. It is also 4 flutes. I think you could see that there because there's 1, 2, 3, 4 cutters on it. This is a similar bit. I could see right here it's a spiral upcut bit. It is a 1/4 inch diameter shaft and a 1/4 inch diameter cutter. It is a flat end mill because it's flat across the top, and it's a 2 flute spiral bit. Over here, this is a 1/2 inch diameter shaft and also a 1/2 inch diameter cutter. It is a ball end mill because the top is a hemisphere and it has 4 flutes on it. So this is a 4 flute 1/2 inch ball end mill. This right here as well is a 1/2 inch flat end mill. It's the same diameter as the shaft itself. It is a 2 flute spiral bit. As you look at this cutter and it spins this way, it's going to spin clockwise. It's an up spiral bit because as it engages the material, the chips are going to move up. So that the advantage of an up spiral bit like this is it's really good at removing chips from the material, but it also sometimes pulls your part up at the same time. Versus a down spiral bit, it's actually going to drive the chips down, which will prevent the chips from getting out from the material, but it will help hold your part down on your worktop. Here's another 1/2 inch bit with 2 flutes on it. It's square top or flat top. Diameter of the cutter is the same as the diameter of the shaft. That doesn't have to be the case, but one thing you do notice on here is all the burning on this 1/2 inch flat end mill. All of this burning happens is because you're not removing heat from the cutting operation. And the way you remove heat from the cutting operation is by transferring the heat from all that friction of cutting to a chip, and then that chip takes all of the heat away. So if you're not creating enough chips, you might not be removing enough heat from the operation, burning both your cutter, your router bit, and your part itself. And that if you're seeing burns on your wood, don't think about slowing down. You might actually have to speed up. Here's another cutter. It is a 1/2 inch mill, 2 straight flutes, but it is on a 1/4 inch shaft. So the diameter of the cutter does not have to be the same as the diameter of the shaft. I think this might be a new one. You could just see how sharp that router bit is. These are both flush trim router bits. This flush trim router bit right here has a bearing on the top. This flush trim router bit has a bearing on the bottom. So you put your template on the bottom, the template would run on this bearing, and then flush trim this to your template. So flush trim router bits come in both styles. It doesn't really matter which one you use. I don't really have a preference over one over the other. The thing that is important is that you remember where to put the template depending on where the bearing is. This is a Roman Ogee. You kind of see the detail it's going to cut. It'll be the opposite. It's a convex curve, concave curve, and then that flat spot right there. This is a really common detail. The height this bit goes through the tabletop, if you're using a tabletop router, will give you the certain detail. Or if you're using a handheld router, how high this comes up through the base will give you a different detail. So if you only want that cove, you could drop this bit down below the tabletop height. Or if you want the cove and that concave part, you could raise it up higher. Or if you want to include that flat part, you could raise it up higher. You really don't want to take out a ton of wood on any one pass. So one way you could prevent that from happening is do multiple passes. Just bring it up a little bit through the tabletop or through the base if you're using a handheld router, and do a pass, then bring it up a little higher, do a second pass, and then bring it up a little higher yet to your final height, and then do your final pass. This is a cove right here with a bearing bit, 2 flutes, 1/4 inch shaft. This is a chamfer bearing bit, 2 flutes as well. You could use a router for cutting dados if you wanted on the side of something. This is a big flywheel here. You're removing a ton of wood. You could change the bearing on the top of this to change the depth that you're going to go into the wood. So it's kind of a cool bit. This one, you know, because of that diameter is so great, these endpoints are traveling really, really fast. So this is a really violent operation using such a large bit like this, so extreme caution really needs to be used. Okay, well that's a quick overview on router bits. Hopefully it was informative. You know, routers are a fantastic tool. You could do a ton of operations. I mean, just looking at the assortment of bits here, you could do a ton of operations with them. I hope you enjoyed the video. If you did, go ahead and hit that like button and think about subscribing if you're new to the channel. Comment below. I'd love to hear your comments, and I appreciate you watching. Thank you.